All right, let's first talk about what type of data is available within order-driven market. First, there are two types of data in such markets, transaction data and quotes data. And first, let me start with transaction data. Transaction data simply provides a record of traded quantities of all assets, along with actual execution prices. So this is really the same as the conventional financial data as we defined or used so far. But there is also one more type of data that we did not encounter so far, and this is called quotes data. So what are quotes? Quotes are proposals to buy or sell a certain quantity of an asset at a given pre-specified price. Now, when we add quotes to actual trade prices, we get not just a single pair of a price and amount traded, but instead we have a number of such pairs of a price and a quantity. Now, let's talk a bit in a bit more details about each type of this data. First, let's talk about transaction data. So transaction data are data that describe actual trades. Every trade has three characteristics: a timestamp, a price, and a quantity traded. Now, this is quite different from many financial time series models. These models usually assume a setting with discrete, equally spaced time steps. But such regular time steps, for example, daily, will only arise after we aggregate all trades within one day. If we look at things at a time scale of a second or below, times between trades appear quite irregular. And in this setting, durations between trades become functions of the price and the state of the limit order book. The next difference is that the price changes are now discrete. They are given by a multiple of a tick, which is a minimal step for a stock price that it can move. In the US markets, one tick equals 1 cent. So this means, among other things, that the price changes are not independent, but rather autocorrelated in the short term. But these autocorrelations quickly decay with time. And in addition, there are also strong autocorrelations in trading volumes. So in a LOB, trades happen irregularly in time. And moreover, durations between trades depend on the state of the LOB. Because of all these new complexities, it seems that a regular time series formulation with a discrete time grid is not adequate here. Instead, a continuous time formulation of dynamics might be preferred. Also, intraday data exhibit strong seasonality. In particular, there is usually lots of activity when a market opens or near when it closes. And normally there is less activity closer to noon. Therefore, intraday data should be deseasoned before it can be used. Next, let's discuss types of orders that exist in an electronic market. There are two types of orders: market orders and limit orders. Let's start with market orders. This is how they work. A market order is an order for a dealer to buy or sell a given quantity X of a stock. Such orders are executed immediately by the exchange via their specialists. On the other hand, limit orders are quite different. They are orders to buy or sell a given amount X, but for a quoted price. If the desired price is below the current bid-ask spread, such order will not be executed, but instead will be put in the queue, as we will discuss in more detail shortly. So all incoming limit orders at each price level are summarized as a total number of orders at each price level. And this summary is called the limit order book, or the LOB for short. Such aggregation is done separately on the buy side and the sell side. And the best, meaning the highest price on the buy side, is called the bid price, and the lowest price on the sell side is called the ask price. When a limit order arrives, it sits in the LOB until it's matched by an incoming market order on the opposite side of the LOB. Or alternatively, it may not wait until then and get cancelled at any time before. Now, the availability of quotes at different price levels lead to new types of data. First, we have the so-called quote data, sometimes also called the level 1 order book data. These data simply collect bid and ask prices and the corresponding quantities quoted. So it only looks at the highest segments on each side of the LOB. There is also more detailed level 2 order book data, which contains information about prices and quantities of 5 highest levels of the LOB. These data are obviously much richer than quote data, but it's also more expensive and takes more storage. And in addition to limit orders, there are also market orders. As we already said, a market order is simply an order to buy or sell a given quantity X at the best price possible. And finally, for this video, I wanted to briefly talk about how trades and quotes data can be used together. First, about data sources. There are a number of providers of such types of data. And one of the best known examples is the TAQ database provided by New York Stock Exchange. Now, when you have both the trading and quotes data, you can use them in multiple ways. And one interesting application is to use them to reconstruct the sequence of marketed limit and limit orders. We can also use such algorithms to infer whether a given transaction was initiated by a buy or a sell side. The method is essentially based on comparison between the trade price and the most recent bid-ask quote. You can read about details of such approaches in the paper that I cite on this slide.